Okay, so now members, let us see how you go through this question. Now we are going to start with the angle below the horizontal, then we shall go to the angle above the horizontal. The angle below the horizontal, basically, it's very easy, no much. Let's go through the question. A stone is thrown from the edge of the cliff and has an initial velocity of 26 meters per second, as you can see. At the angle of projection, theta, now that theta is there. Below the horizon, I think it's at the sea. Below the horizon, this is the horizon that's below. The stone hits the sea at a point level with the base of the cliff. This stone now, when it's thrown, it hits the sea at the point which is level with the base of the cliff, as you can see. Say at 72 meters away from it. So 72 meters away from it. Find the height of the cliff. Then the time for which the stone is in here. Now they are asking for the stone when it's in here. Count that. So there what happens is we first put our angle. This angle, remember our angle here was given by tan inverse of 5/12. So now we start with that. So our theta is tan inverse of 5/12. Straight away, convert it in terms of tan. So our tan will be 5/12. Why don't you get the angle here? Because we are going to get some errors. So get the tan itself. So after that, if they want us to get the height, so they are not giving us anything like time. So what are we going to do there? So what we are going to do, remember from our first equation, x will be equal to u cos theta t, and then our y is going to be equal to u sin theta t, then plus a half b t squared. So see if they don't give us time. So I make the subject here. My t will be x over u cos theta. And if I substitute here, I'll be having now my y into sin theta into x over u cos theta. Then plus a half b into x over u cos theta, the whole square. If we simplify that, shall get our, this one will cancel. This will give us x tan theta, then plus. Now here the gravity is positive. Why? Because from the initial point it's just falling, but if we see it's going up, like we see in the when the angle is above, that will be negative because it first of positive, but this one just falling from the initial point. That's why we take our b to be positive. So this will be now b x squared into this one. We are going to get cos squared, 1 over cos squared, which is sec squared, and sec squared is the same as 1 plus tan squared theta, the whole over this 2u squared. So from there, you start from there, our y is going to be our h. Our x is the distance covered, which is 72. And then what else? Our b, the question is telling us that our b we are going to use 10. So putting them here, our y now, our h will be now 72 into tan theta is 5/12, then plus 10 into 72 squared into 1 plus this one is 5/12, the whole squared. Then we are dividing with 2 into our u, which is 26. Our u is 26. So here is our h. And simplify this one, you'll get 6 times this, which is 30. Then plus this is going to be 45. So our h is going to be 75 meters. So meaning from here to here, it's just 75 meters. So now they want us to find the time which the stone hit is in the air. So this time here means that it had covered from here up to here, it had covered horizontal distance of 72. So now in part B, we are going to say that from our x equaling to u cos theta t. Now it's that we have this, we are missing this. And now remember from our tan theta, it was 12 over, it was 5/12. 5 5 over 12. So I can easily come and I use my right angle triangle. So this one is going to be the opposite, adjacent. So when you square this, plus square this, then the square root, you will get 13. So from there, it's that my cos, now theta is going to be adjacent over hypotenuse. So now from here, I have 72 equaling to my, which is 10/6 into now 12 over 13 t by this one, by this 2. So I have 72 equaling to 24 t. And so my t will be 3 seconds. And that would be our answer. Meaning, the part of cover from here up to here, it's now the time it will spend in here is when it reaches here. That would be 3 seconds. So, that's how we handle that. We are going to see more examples, some examples about the angle below the horizontal, then we'll go to the angle above the horizontal. See you there.